this video, I'm going to show you the solutions to the question paper from 2023 supplementary exam. So question 6.1 says, a bag contains 12 red and 7 yellow marbles. So you have 12 red and then 7 yellow marbles. You are asked to select 2 marbles from the bag. The first marble selected will not be placed back into the bag. Then 6.1.1, construct a probability tree to indicate the various possible outcomes and their probabilities. Express the probabilities as fractions. So here, the important thing is for you to note is that they say that you are selecting 2 marbles. The first marble you take, you're not going to place it back. That's very important for you to know, because it means after taking the first marble, the number of balls reduce. Okay, now let's go. You have red marble and yellow marble. So they said you have 12 red and 7 yellow, so you have a total of 19 marbles. It means the probability of you having red is going to be 12 over 19. Why? Because you have 12 out of the 19 marbles total. So the probability of you finding red for the first time would be 12 all over 19. And the probability of you getting a yellow marble would be 7 over 19. Right? Because you have 7 marbles all over 19. That would be the probabilities on the first round when you are selecting the first ball. Now we go into the second balls. Again, it could either be red or yellow. Again, here is in the case whereby the first one you selected was yellow, and then it could also be either red or yellow. So here, if you first selected a red marble, then it means now the number of red marbles you have left is 11. Why? You had 12 and you took 1 out, and as the instruction said, the one you take, you don't take it back. So it means now you have 11 red marbles left because you took the first one here, right? Another thing for you to note is that because you took one marble out, you now have a total of 18 marbles left. So here, then the probability is going to be 11 over 18 of you taking a red marble again. Why? Because you now have 11 red marbles left if the first one you took was red. And now your total number of marbles is 18 since you took 1 marble out. But when it comes to yellow, if the first one you took was red, then you still have the same number of yellow marbles. So you still have 7, but now divided by 18 because your number of marbles has changed to 18. So that is the first branch in the case whereby you take red and red. Then the second, the first would be 12 over 19, and then the second 11 over 18. Then the second branch, the probability of first red is 12 over 19, then the second yellow is 7 over 18. Now let's go to the case whereby you first select a yellow marble. So as we said that the first one is 7 over 19. Then the second, if you're gonna take red, how many red marbles do you have left if the first one you took was yellow? Then you still have 12 red marbles, right? So you still have 12, but the total is now 18 because 1 marble was taken out. Then if you first took the yellow marble, 1 yellow marble, then how many yellow marbles do you have left? 6, divided by the total of 18 because 1 marble was out. So these are the probabilities for the second branch. Now for you to find the probability for taking this branch red, both red, you would have to multiply the probability of first finding red and finding red again. And then for probability of finding red and yellow, you have to multiply this by this probability. Then probability of finding yellow then red would be 7 over 19 times 12 over 18. Then the last one, yellow then yellow, would be 7 over 19 times 6 over 18. Now let's calculate our probabilities. So finding both marbles red would be 12 over 19, which is the probability of first red, 12 over 19 multiplied by 11 over 18, which is 22 over 57. And then the second one, 12 over 19 times 7 over 18 is 14 over 57. Okay, this one too, 7 over 19 times 12 over 18 would be 14 over 57. Then the last one, 7 over 19 times 6 over 18 would be 7 over 57. And then when you sum up these probabilities, you're supposed to get 1 because that is the collectively exhaustive set. Okay, so the question after that says, what is the probability that two selected marbles would be different colors? So if the marbles are different colors, you either having red, first red, second yellow, or first yellow, second red. So it would be the probability of finding red then yellow plus the probability of finding yellow then red. It would be 14 over 57, which is this probability, right? Plus 14 over 57 for yellow and red. Then that would be 28 divided by 57. Okay. So the question after that is different, is on conditional probabilities, question 6.2. So I'll just start on a new page. Question 6.2 says, the probability that a randomly selected employee of company Z lives in East London is 0.75. The probability that an employee of the same company works in the research and development department, given that the employee lives in East London, is 0.2. What is the probability that a randomly selected employee of the company would live in East London and work in the research and development department? So this question is the conditional probability question. It was testing if you understand that. And how do you know? Because it says given that. You have the given statement, right? So let's write what they give you and what they want. So it says the probability that an employee lives of that company Z lives in East London is 0.75. So I will just write probability EL for East London is 0.75. Then they say the probability that they work in research and development department, given that the employee lives in East London, is 0.2. So they say the probability that they work in R&D, I'll just write R&D for research and development, right? Given that they live in East London is 0.2. And they want the probability that they live in East London and work in research and development. So they want the probability that they live in EL and work in R&D. Okay. So this is the unknown. We know that the conditional probability is the probability. Okay, let me just write here. The probability of A given B is probability of A and B over PB. So you either know this equation this way, or when you cross multiply, take this here and this here, it would be probability of A and B equal to probability of A given B multiplied by probability of B. So this is the same equation for conditional probability, just that the other one, this one, you get when you cross multiply. So it means the one we're going to use is this one, because we have the condition and the marginal probability for B. So it means the probability that the person works at East London and works for R&D department is going to be the probability that they work for R&D given that they are from East London, right? That is the condition, multiplied by the probability that they're from East London. So that would be 0.75. Oh, EL is 7. Okay, anyways, multiplication is okay. 0.75 is the probability of East London, and the conditional probability that they work for R&D given that they are from East London is 0.2. So this is 0.2. 3/20, which is 0.15. So that would be 15%. It means there's a 15% chance that they are from East London and working for research and development. Okay, I'm out of pages. Okay, the question after. Question 6.3. 6.3 says, Vusi is the manager of chemical research department of a large multinational company. He has 17 members of staff working for him. He has to choose 8 members of his staff for a project team. What is the probability that you would select the same team as Vusi? So here, as you can see, that like they are saying that Vusi wants to choose a team, right? He has 17 members. So N is 17, but out of the 17, he wants to choose 8. Then R is 8. And in this case, they just say that he has to choose a team of 8 members, right? So it means this is the case of combination. And why is it a combination? Because the order of arrangement doesn't matter. They didn't say anything about the order. They didn't talk about being distinct or that like they need a specific order or something like that. They just said a team, which is how you know that this is combination. So it's going to be 17 C8, right? You can get this directly from the calculator, but I'm just going to show you the whole process. You know that combination is n factorials divided by r factorials times n minus r factorials. So it's 17 factorial divided by 8 factorial multiplied by 17 minus 8 factorial. It's 24,310 ways. So to get this from the calculator, you just say 17 shift button, division button, and then 8. Then that would give you 24,330. The question, however, wants the probability that you would select the same team. So in terms of the teams, it means there's the different teams that you could select at 24,310, and each one is different, right? So what are the odds of finding the same one? Would be 1 divided by 24,310. Well, I mean, you should leave the answer like this. You can see that it's going to be 0.000004. So likely you had to leave the question this way. Okay. And then 6.4. 6.4 says there are 11 teams in a local women's soccer league. What is the probability of correctly predicting the top 4 teams at the end of the season in the correct order? So this question is permutation. Why? Because the order of arrangement is important. They are specifically asking you of predicting in the same order. Right? That there are 11 teams in the women's league and you want the top 4. So it means N is 11 and then R is 4. You want 11P4. So you know that the formula for permutation is N factorial over N minus R factorial. So it's 11 factorial over 11 minus 4 factorial. 7,920. So the probability again that there are 7,920 different orders of arrangement. And what is the probability of you finding one? Since they're all unique, so it's gonna be 1 over 7,920, which you had to leave like that. So now I'm going to show you the probability question whereby they ask you to find their probability when they tell you that like you have mutually exclusive events and independent. So this is the question from test 2 2022. So the question says even x and y are such that px equal to 0.2, px union y 0.55. Given that x and y are independent and mutually exclusive, determine py. Give your final answer as a percentage to 2 decimal places. Here they told you that px is 0.2. And that px union y is 0.55. They told you for a reason that the events are non-mutually exclusive. If events are non-mutually exclusive, you know that probability of x union y is probability of x plus probability of y minus the intersection between x and y, probability of x and y. So what I was explaining that is because you double count the intersection. Px has the intersection, py also has the intersection. So there's a double counting, which is why you subtract px and y. And then they told you that the events are independent. If x and y are independent, then you know that px and y is px multiplied by py. So this is non-mutually exclusive and then this is independent. Now substitute the independent into the non-mutually exclusive. Then you would have probability of x union y is equal to probability of x plus probability of y minus probability of x times probability of y. Right? You have substituted this into this equation. Now let's substitute the values that they've given us. Probability of x union y is 0.55, so it's 0.55. Probability of x is 0.2, so 0.2 py is the unknown. Minus, again, substitute the 0.2 there, 0.2 py. Here you have to transpose the 0.2 here. Is the constant, right? 0.55 minus 0.2 equal to. Then py minus 0.2 py, as you can see, you have to take out the common factor py. So would be 1, because the number here next to this py is 1, minus the 0.2 here multiplied by py. So 1 minus 0.2 is 0.8 py. 0.55 minus 0.2 is 0.35. After that, you can see you have to divide by 0.8. Then eventually you would find that py equal to, let's check. Okay, so 0.35 divided by 0.8 is 0.4725. So that would be it. That's how you calculate your probability. Thank you.